Alright, hi you guys. We'll talk about transforming polynomial functions, and it's just like transforming any other type of function. You have to pay attention to the a, the h, and the k, and just work with it that way. And then we'll also talk about power functions and their constants of proportionality. Okay, so right now we're just taking a look at this bad boy. This is just the medley of graphs I have on my page for my Desmos for you guys, okay? Alright, so we'll take a look at these two. We'll ignore those. Okay, so once again, the quadratic function, the cubic function, if you have a's in the front of the vertex form, okay, you've got h's, you've got k's, okay, and the b's we will explain in pre-calculus. So don't worry about the b's for right now, but the a's obviously control the slenderness or the skinniness of the graph, and if you notice the snake also moves with it, okay, and even if I do have something else that is like to the fourth power, it will do the same. Okay, same with the h's, we'll move it left and right, backwards to what you know, and the k's will move it up and down, okay, alright. On the h's, be careful when you're moving them and stuff. Make sure you graph it to just double check to make sure it matches your information that you need. Okay? Alright. So that's it for that part. Now the power function, oh, you know what? We do have the power function right here. It's this bad boy. Okay. Power function is actually a number which we call the constant of proportionality. In other words, it's the beginning number. It's almost like the principal value. Okay, then we have our ratio right here as b, and then you can actually transform it with h and k, and it follows the same rules. Now, if b is 1, no matter what power you raise it to, it's always going to stay the same. But the second we start making it 2, it starts going up at an exponential rate, hence the name exponential function. Okay? So if we zoom out a little bit to take a look at this entirety of the graph, if we make a bigger, it makes it steeper, and it also changes the y-intercept from 1, which is the typical normal intercept and everything. Okay, if we change b, however, if we change the ratio, no matter what, at the y-intercept where x equals 0, it's always going to be stuck to that 1 point. Okay, now I can't make it negative because this stuff, I can't find those powers. Okay, so you have to understand it has to be 2 or more for this. Now the h's do the same, except they're going to give the illusion of moving to the left. Okay, they do increase the power, so they are increasing it a little bit more. Okay, alright, and k is going to move the entire thing up and down. And you can definitely have negatives with this k, so it definitely works out. Now, if you do have negatives with h, okay, it's just going to make it smaller at this point. Okay, now here's the cool thing. If we make b, if we make it negative and work around it, you're actually going to see that you're going to get some impossible situations. So be careful when you're working out on this. Okay, just be very careful how you work with this one. Alright. So that's pretty much it for just working with families of functions and everything. And just remember, this is the constant of proportionality. Okay, and remember, if y equals ax squared plus, or ax to the b power, okay, then y varies directly with or is proportional to the bth power of x. So this is something else that you could say about it. So for example, y equals a times x to the bth power. This means y varies directly with or is proportional to x to the bth power. And bth, I mean, it could be just basically any power. Okay, so just remember that this is also a direct proportionality problem that just works the way it is. Okay, that's transforming just like usual. It's nothing new, it's nothing fantastic, it's nothing crazy. It's just transforming and working with it. If you got your graphing down, this should be pretty easy. Okay. Alright, feel free to use your graphing calculator in Desmos, and have a great day. Bye.